Enzymes.
Hey, Professor. Just the other day, I saw this small man swallow an entire steak bigger than the size of his head. And it got me to thinking, how could he possibly digest all that in just a few hours?
Well, the steak is first chewed in the mouth into bits and pieces that fall into the stomach. You might already know that the stomach contains a powerful acid that can dissolve even metals. But what you did not know is that this acid is not what ultimately breaks down the steak. No, it's very tiny and special molecules called enzymes that do the job. Strangely, these enzymes find the stomach acid a cozy place to work in.
Whoa! It's like small piranhas finishing up a whale in a sea of acid. Imagine what I could do with that.
Ooh. Huh?
Well, it doesn't work that way.
What do you mean it doesn't work that way?
I knew you were going to say that. To find out, you need to know what exactly enzymes are and how they work. Whenever you're ready, click Next to continue. What are enzymes? They are proteins that speed up chemical reactions. Without them, reactions can still occur, but they would be too slow to support life. There are many different types of enzymes, and they come in all manner of shapes and sizes. For example, what you call the piranha enzyme is actually pepsin. It is only found in the stomach and digests proteins. In your mouth, there is amylase, which breaks down starch. In your cells alone are hundreds of enzymes that control your cell activity and defend them from invasions by microbes like bacteria and viruses. Though enzymes can appear very different, they all share a few characteristics in common. Let's now take a look at what these are.
Enzymes are protein molecules that speed up chemical reactions in the cell. A special region on the enzyme, called the active site, is the area where enzyme activity takes place. An enzyme works by binding to molecules, called substrates, at its active site. The job of the enzyme is to convert the substrate into a different product or products through a series of chemical reactions. Following the reactions, the products are released and the enzyme is free to act on another substrate. At the active site, the substrate should fit into the enzyme almost like a key fits into a lock. Because of this, most enzymes can fit only one substrate. To accomplish this lock and key fit, the active site undergoes a slight change in shape in order to better accommodate the substrate. This is called the induced fit model because the enzyme is induced to undergo small changes so that the substrate can achieve optimum fit.